Good day to everyone and welcome to our first cloud coaching session of the year. My name is Violeta. Today I'm happy to be joined by my colleague Tom and my colleague Ettore from the Oracle developers team in Oracle Marketing EMEA. Today we have two special guests who will be your speakers. So we are happy to be joined by Wojciech Pluta and Victor Martin, who will be your speakers and your guided tours for this session. Today, we talk about OCI DevOps. So you will learn how to speed up your application release cycle with DevOps and Kubernetes. And then you will see a demo on how to deploy a 3D multiplayer game on our Kubernetes cluster. You have the possibility to do it yourself together with us today, or you can play it afterwards. We will share with you a link to the lab that we created for this session. So you will have the possibility to test these codes in your own environment. I think that was all on my side. Wojciech, over to you.
Thank you very much, Violeta, and Happy New Year to everyone. Great to have you on the call today. I'm very excited to take you through the session. So this is essentially a session that we built together with Victor for our cloud world last year. And what we're doing now, we're trying to broadcast it so that you can experience and play with the services as well. So my name is Wojciech. I'm part of the our app development team and as part of our technical marketing. So my role is global, and we're working on the different frameworks and helping you develop great solutions on Oracle Cloud infrastructure. Victor, do you want to give a little intro?
Sure. Hello, everyone. Thank you, Wojciech. So for me, I'm Victor Martin. I'm Technology Product Strategy Director, and I basically create content, and I'm software developer at heart. So I create all of these interesting things and play around with technology and bring it to you so you can enjoy it. So hopefully that's the case for today's session. I'll see you in a bit on some of the demos that we have ready for you today. Thank you, Wojciech.
Thank you. Okay, cool. So let's move on with the slides. Hopefully you can see them. So the agenda for today is going to be split into a few sections. So we're going to have a little bit of intro around talking about the journey that we went on when we built this with this demo. So yeah, we actually branded this game and we called it Save the Wildlife. The concept is actually inspired through some stuff that we saw over in the cloud world and so on. And then essentially it's the journey of how we build it and how we put it all together for you. And we're going to give you an overview of our services that we use. So predominantly in this case, we're using OCI DevOps service. By OCI, we mean Oracle Cloud Infrastructure. And then we're going to dive into the actual workshop that you can access, and we're going to share you with the links of where to go and then how to give you a little demo in terms of each of the steps. So and then we're going to end it up with the wrap up and any questions that you might have, next steps, and any other sessions that we'll be running soon. So the next slide. So Save the Wildlife. So as I said, we branded it, but initially we started with the name of the OCI multiplayer. But we thought it might, since it is essentially a Three.js game, let's have some fun with it. So what you can see here is development process of the game. So the left-hand side, it was the initial sort of testing and building and working on the logic. And how it started. So it was not as nice looking and using all the shaders and things like that Three.js allows you. And then obviously through the iterative process of the development, we were able to make it a little bit more pretty and a little bit more robust in that sense. So lots of learnings in terms of how to use Three.js and the framework. But what I would like to do is actually do, while we having those sessions, we like to stress test the solution. So what I'm going to do, I'm going to share you with the link, and hopefully we can all join and have a little game of the with it. So hopefully you should be able to access the link. In some cases, there might be some issues with your network providers and VPNs. But if you can join, it would be great if you just type in your name, and then hopefully we're gonna start seeing people coming up. Yay! So so as you can see, the game itself, it's relatively straightforward. It actually expands as more people joining in. So the concept is that we have to collect the boxes and then avoid the green stuff. So as you collect the boxes, you're gonna get a score that's gonna be shared in as your dedicated score in a leaderboard. And then as we go through the environment, you need to avoid obviously the wildlife, because that's going to penalize you and taking away the points. So it is getting obviously crazier and crazier in terms of more people joining, more objects going to be spawned. So that is on its own, quite interesting to see, how we get more people joining and all the blocks appearing and disappearing. And but as you can see, the game logic, it's relatively straightforward. We have time that is controlling essentially when your game over and your game gonna finish. So within that time frame, you have to collect as many objects as you can. And then we have some mechanisms running in the background that we're going to cover in a minute in terms of how we managing, that the fact that we having the scores, we having the people collecting and interacting with objects, and so that way your score is being captured in the correct way. So as I mentioned, all the data with regards to the information of your score is going to be captured in the Oracle Autonomous Database, which allows us then to obviously have the leaderboard and stuff like that. I mean, the concept is relatively simple. We are not, hardcore game developers. We love to play with the technology itself, but hopefully, this allows you to create and iterate through, the DevOps and interacting with Three.js as a framework. To then have some fun and maybe change the game logic, add additional shaders, objects, or anything like that. So yes, that's the essentially the idea of the game. So we moved, like I said, from the sort of top-down view into the third-person camera. That obviously creates a little bit more interesting experience for the users, giving you the chance to see a little bit more and put the Three.js shaders into a bit more of work. So I'm 2 seconds away from the game. So there it is, game over. So my score is 27. So now my game session is finished, and that's gonna send a request back to the database to see this to capture the score. So that's kind of it in terms of the concept of the game itself. Hopefully, you understand and you had a little bit of fun while we are doing this. So going back to the slides, so why we chose Three.js? Well, Three.js, it's one of my favorite frameworks in terms of the open source frameworks. It allows you to build some very engaging experiences. There's quite a few other frameworks that were built on top of it, like A-Frame, that allows you then to leverage the principles of the Three.js and build even VR or metaverse type of experiences. And obviously, by providing the backend infrastructure for the communication between the pods and the server, and so on, allows us to then build, multi-user experiences. So you could essentially, change this front end into, something VR based or first person based, and then, you have all the communication happening in the background, allowing you to have the multi-user experiences, and all running on Kubernetes, so very scalable and a very modern way in terms of, running it as a microservices and so on. The very important thing to mention about the Three.js is that there is a lot of community support, as well as there's a fair bit of advancements in terms of pushing that framework to allow new sort of ways in terms of how we deliver experiences. We have some web GPU compatibility coming up. So there is a development happening right now. So meaning that, we will be able to use, your local GPU in terms of, providing even more, engaging experiences. So that is something definitely, if you're interested in terms of, building experiences like that, it's something very sort of future-proof. And with, like I said, the web GPU modern API, that's allowing you to access the capability of your GPU in web apps, right? So it doesn't need any compilation. It's literally running in a browser, and hopefully as the time progresses and the frameworks gets more and more features, the experiences itself can be much more, better in terms of the graphics. So just a few words about the Oracle Cloud itself. So as I said, our application development services and tooling consist of, possibilities for you to use any code that you is your preference. So you can use, any language code on it. We provide, flexible infrastructure that enables you to scale and have a secure and performant application. So as it is, a platform that is allowing you to innovate, we also have the capabilities of Java, Graal VM, and other support, open source languages like Three.js and so on. We also offer integration services that allows you then, to scale and so on. As well as our, database solutions and AI that we're investing in and releasing new and more, features and so on. So with things like an autonomous database that we're using in this case, you also have MySQL HeatWave that, allows you to scale and run, both analytics and transactional workloads in the same database. We also have things like low-code platforms, like Apex, allowing you to then build others, quickly solutions. But then in terms of the runtimes and core infrastructure, we have, the GPU, we have the compute CPUs and Kubernetes engine that we mentioned, and like I said, we're building intelligence and other, AI components to it. On top of that, we have observability, security, and governance that you saw briefly at the beginning, and all sort of wrapped and very sort of accessible across the globe, because we're investing in our data centers. So in the case of of the game, obviously the latency can be an issue sometimes, with so you want to be your users as close to the the data centers to have the best possible experience. And by having so many regions and clouds available with Oracle, you can deploy wherever your users are and then scale automatically from there. So very quickly, I'm going to tee a little bit about the DevOps and pass on to Victor in a minute. But the reason we wanted to obviously talk about the DevOps as a practice of improving how your teams develop software. When we talk about DevOps, it's just not the service in general. We like to talk about it as a practice and a little bit of a culture shift. in terms of how you think about, where your team is and how you can actually scale and automate your deployment pipelines. Victor, you to take on from here.
Yeah, good. You can go to the next slide. Anyway, you all recognize this symbol is the default symbol of how CICD works. On the specifics on OCI DevOps service is a continuous integration, continuous deployment platform, and it's built for automation. It increases your chances to deploy your application in a fastest way. That is the most important part you can do, and also reliable. You can trust that everything will be executed the way you program it. In terms of security, we are leveraging all the infrastructure behind Oracle Cloud, so IAM, identity and access management, so the users will have different permissions, the same parts of the build pipeline and deploy pipeline, everything that is happening on that workflow of the software from the code all the way to the production environment. All of that has different roles that can be assigned and permissions that can be applied. And also it can be integrated with vulnerability scanning, security zones, CloudWard, all the technology on terms of security. And finally, the governance, because it's deployed in the cloud with OCI, you can track issues and take a look to what is happening inside of the platform. And that regarding the service as a whole, we can go to the next slide and discuss a little bit more of the features that it has. One of them is that it's serverless. You can forget about creating the master node and then worker nodes that are going to execute the code, the building process. In this case, it's serverless. Everything is behind the scenes using container instances. That is like an instance behind the scenes that you don't have to manage. And it's running a container where inside of that container is doing the build pipeline, the deploy, doing the different steps, including the test, running the test, for example. So that's one side. The other part is integrated. It's integrated with all the other services. So you can run the build pipeline with repositories. The integration includes GitHub, GitLab, Bitbucket, and other services like that. But also includes their own Git server. So basically, you can just work with all that security embedded and deploy your code directly on OCI DevOps. And finally, native CICD platform. So you can create a workflow that is going to deploy in Kubernetes cluster, in serverless functions, and things like that. Really interesting platform to explore. Yeah, we can go to the next slide to cover a little bit of the overview of what we are going to build. So the complete continuous integration and continuous deployment overview is that. Basically, you have the green box where you have everything that is regarding your code all the way to deploying in production. That is all the way on the right side. So the first step will be to commit your changes, build your code, and just deploy it on the server. Either an external one and then allow OCI DevOps to migrate it internally, and then the build pipeline. The build pipeline is transforming those source code into deliverable. The artifacts is the concept. So basically, building and running the programs that are going to compile the code and things like that, run the test, and as soon as everything is tested, you can deliver the artifacts. And you have two main things. For example, think about a configuration file, a dynamic file that has to be specific for the build that can be deployed as an artifact. Other things can be container instances, for example, if you are deploying in Kubernetes. So for that, you will use a Docker version 2 compliance Docker registry, and that is container registry inside of Oracle. So everything lives inside of Oracle in your region. And that's it for the build pipeline. Then we can maybe take a look to the UI. I'll probably have time later to show you a little bit about the build pipeline on the UI. But basically, you select how big the instance is going to be to run your code. So you have to do a little bit of testing on how big your compilation project is going to be, and then select the different infrastructure. Other than that, you are done. You don't have to spin, synchronize, create a worker node that is going to take over. Everything is automatically done for you just by selecting this simple form. Yeah, on the next slide, we will talk about the other part, the continuous delivery. So in this case, we have different release strategies. So that's important because maybe in some cases you are going to do a blue-green. We are going to deploy in a canary type of release strategy. So basically, depending on your needs, on your business needs, you will deploy it in a separate environment and then redirect the traffic to the next one. All of that can be automatic with OCI DevOps. And then connected, you can connect all the workflows, so everything is nice and tidy, and you just have manual steps or completely automated from 0 to 10. And then the rollback, if something goes wrong, depending on the type of release strategy, DevOps even can take an automatic rollback based on some parameters. So that's an interesting part. But you can also do a manual rollback depending on the case. So all of that can be easily done depending on how you deploy, depending if it's virtual machines, if it's a Kubernetes cluster or serverless functions. And that's everything about the continuous deployment. On the right side, you will see the deployment pipeline as an overview. And in this case, we are going to deploy those artifacts that come from the previous pipeline, the build pipeline. We are going to take them, deploy them in DevOps, in dev environments, in different environments, UAT, whatever your infrastructure looks like. Do the integration test if you want, and then if everything is approved, then you can deploy on production, and that will cover compute, any shape, virtual machines, bare metals, etc. And then container engine for Kubernetes, that is our Kubernetes platform, and serverless functions. So with that, you can actually cover everything that is required for building your source code into actually products that run on the cloud. This is how it looks like on the UI. So you can see that there are different ways to deploy depending on if you use Helm for Kubernetes, if you are deploying in different strategies. You have the blue-green there, the canary strategy. You can select what you are building on the deploy. On the control side as well, you want to pause the deployment for approvals, for manual approvals. You can actually split the traffic so you can redirect to different environments. And you can also wait, that is like merging different pipelines that are happening at the same time. And integrations, so you can actually go really low level and execute commands and things like that. That is actually the case that we are using, probably the toughest one, but at least you have an example of the difficult one, and then the rest is more automated and simple. So you will have a nice experience with OCI DevOps.
Sorry to put you on the spot, Victor, but quick question. So in our case, we use customize. Can you touch a little bit about that and the reason and how it was to use that and give a little bit of a sort of overview of that?
Yeah, so there are different ways on Kubernetes to deploy, some of them more manual, but basically at the end, the idea is to put YAML files into the Kubernetes cluster. There are different paths. One of them is the traditional manual deployment, not recommended, but good for testing. And the other two that you probably will have at your company is the Helm and then Customize. Customize is now part of the executables that you install when you are installing kubectl and things like that. So, and basically one works a lot with templates that you are changing, and it gets a little bit messy. That is the way I was deploying for a long time. And the other one is customized, that is more like going in one direction, like functional. This is the way I want to deploy it, and you append different changes. And the aggregation, all of those YAML files will be your final deployment. So allows you flexibility for deploying the same things like a base application, but then change the specific things with nice YAML files on, for example, dev environment. You want to limit the resources. In UI, you are going to do a stress test, so you want to create more replica sets. So that is nice about customize. But anyway, even the whole options that you can deploy on Kubernetes can be covered with OCI DevOps. That's the important part, because you will have different options depending on what company you are working for or what type of projects you are deploying.
Perfect.
Hopefully that answered the question.
Yeah, no, that's perfect. Yeah, let's move on to the application flow. You want to?
Yeah, so the application that Wojciech and myself we've building, we use different type of databases. That's probably interesting for most of you. But the idea is that the browser will go to the load balancer to get the static content from the web server. And then the next step, that static content, JavaScript, HTML, and so on, it will be executed on the browser. And the request will be a WebSocket server going to the server that will use two databases. One is a Redis database for the public subscribe for the internal scaling of the WebSocket server. For you that are familiar with WebSocket servers, you know what I'm talking about. And the other part is the coherence, Oracle Coherence, the community edition in this case. That is an in-memory database, really fast, and that is where the state of the game is stored. So that means that if one of the servers goes down, one of the others can take over, and that is why we have the Redis and the coherence in there. And then the other part is for the score. All the score will be in an autonomous database, and I'm not sure if I'm missing anything, Wojciech, or something that you want to add, but that's kind of like the overview of the architecture of the application.
Mm-hmm. Well, also the good thing would be the mentioning, I guess, the Spring Boot, right, and usage of that to manage the connectivity to the database and that.
Yeah, correct. In there you have the code for a Spring Boot application that is the one talking to autonomous database, and that's the idea. You can take the example is using Spring Boot, so Hibernate and whatnot to deploy the application. That probably will be a case that will happen to many of the attendees today using Spring Boot. If you are using Java, it's probably Spring Boot. How to interact with autonomous databases, with Oracle databases. There are good examples there, but you can take the code there as well if you want.
Awesome. Yeah. So I think that's a good way to segue. Obviously, as you can see, it's quite a lot of networking connectivity involved in there, right? So one thing to mention here is that there's been done some analysis in terms of the traffic pricing across the various clouds, and Oracle Cloud seemed to be one that's the most competitive on the pricing. So I think in a case, if you're thinking of running, the applications that require some, inbound and outbound connectivity, we are the most competitive in the market. So it's, it's definitely worth considering in terms of, if you're thinking of deploying something like that, where the concurrency is important and so on. Definitely recommend you to check this out and so on. So I'm going to move on to the introduction of our lab itself. So as we mentioned at the beginning, well, this is part of something that we delivered in our cloud world last year. So essentially, we packaged everything up, all the source code. We pushed that into the GitHub and our Live Labs repository. So essentially what Live Labs is, Oracle Live Labs, is a place where you can go and have a play with our technology and actually experience getting this up and running. Our sort of intention with building this was like, well, if you want to take anything as a building block and then put your own spin to it, that was sort of what we wanted to do with this. Therefore, we release all the code and what we just discussed, and it's all available for you to play with. So considering that you're gonna get, obviously, I think it's $500 if I remember right, in terms of your trial. I think when I deployed this, it on the initial stand-up, it was around $30 to $40 that it costed us to spin it up. So obviously, it would depend on what sort of configuration you're gonna do, whether you're gonna add some additional features or additional configuration of your nodes or storage or something, whatever you decide to do. But yeah, like I said, our intention was to give you this. We are looking to add additional features down the line, but you can, like I said, access that and go through the steps yourself. Today, we're not going to be taking this kind of like, oh, you guys do this, and we're going to sort of wait for you to complete each of the steps. We are just giving you an overview, but yeah, you can definitely reach out to us or contact us through the Slack channels or even raising the PRs in terms of the pushing your changes. If you do something, we want for it to be a living and breathing kind of a repo where hopefully we can get some contribution from yourself and get some ideas from you. At the moment, we're lacking, for example, observability, so we're looking to add that down the line. And then additionally, we're looking at the different ways of how we can, take the lab forward. So it's pretty straightforward. Once you land on the link that Violetta just shared, all you have to do is click start, and then when you click run on your own tenancy, that's going to take you to all the steps that we're going to briefly touch upon in a minute. And then the workshop, in terms of sort of general structure, what we have is we have 1, 2, 3, 4, 5, 6, 7 steps in total, including the cleanup. So obviously, if you sort of do it and then you want to sort of remove to free up your resources, there's automated scripts to help you with that. But at a high level, we obviously talking cloud native deployments. So we're using GitHub, we're using tokens and forking and cloning of the repo to move that into the DevOps environment, and then we're deploying through some infrastructure and DevOps project through the Terraform, and then we sort of interacting using UI to build pipeline and then run the deployment pipeline. And then we actually have also a scenario when you can do release to and roll back, just to again give you a bit more sort of playtime with the environment itself. Right. So the next part is we're going to take you through at a high level through each of the steps, and we're going to give you a little demo of the UI. So feel free to keep the questions coming, and if you want us to focus on a specific part, we try to do that too. So the first step is of the lab is to actually forking of your repos. So we're doing that through generating access token for your forked repository. So we would give you the link to the DevRel one, which is where this is hosted, and then allowing you to create that connectivity to your personal fork and access rights and so on. So and then once you complete this, you're gonna end up in setting up your local clone that can then be worked with using the shell commands. So we're gonna kind of talk a little bit about it in terms of how it actually lands in your DevOps project. Initially, it's going to be requiring first, setting up the project to actually get to the point that Victor is just going to show you. But it's just literally the case of running few shell commands and so on. So, Victor, you happy to talk a little bit about the mirroring and
yeah,
how the
sure.
looks?
Absolutely. let's take a look. So you should see my browser now. This is Oracle Cloud Web Console. This is the menu already opened. In case I will do a little overview about how to find the service and so on, but also drill down into that connectivity with GitHub repositories. So if you go to developer services and then in DevOps section, you can go to overview or projects, but overview will be good for this. Project is kind of like the main entity where everything will live. So if you have a project, different projects, you will create those different projects, and inside of those connections to different GitHub repositories have different build pipelines and so on. Everything is created with Terraform, so everything is automated. You will see it as the same way I did. I see it, and this is the projects. In my case, I have one, the DevOps project for this webinar. And if you drill down into it, you will find different entities. Those entities are also here in the main page. You can do the typical operations, the CRUD operations, delete, edit, and so on. But the one I want to pay a little bit more attention is the GitHub mirrored repository. So if I click on that one, I will see that I have a GitHub repository there with all the details. On some of the questions, some people ask about how to build specific things. And in general, every time you want to build something using a technology, using some specific third-party technology, all of that will go into stages inside of your build pipeline. So your build pipeline will have different stages, and those are the ones you can program to do specific things. That's it's explained on the documentation as well. You can take a look, and that's it. You will have the files, and in this one, you can see a little bit of the files, and work request is interesting because you will see the different processes of mirroring, how are they completed. So as part of the hands-on lab, you will deploy this mirroring synchronization with a security, with a token for security, and that is the way to check that everything is working. If you come back to the details from time to time, actually, happy days, you will see that mirroring is in progress. So that's a good indication that everything is working fine. Yeah, come back to the project, and I think that's all. Wojciech, do you want me to cover anything in specific? Any other thing? You are on mute. You are still on mute. You are taking over.
Sorry, I think there's a question around are there any options for code review?
Yeah, absolutely. That will be either part of the GitHub repository living inside of the OCI DevOps, or will be part of your GitHub. If you are using GitLab or GitHub or Bitbucket, you will do the code review. By the time you merge on the branch, whatever branch, in this case, if you are going to release off a main branch, then all the code will be there. And as soon as that code review is done and performed, then you kick off the build pipeline. If in your case it's more complex and you want to create different environments for different things, you just need to hook up to that specific branch and then deploy from there. So it's up to you. It's quite flexible in that sense.
Perfect. Thank you. Okay, moving on. So the lab 2 is where the magic happens. Yeah, so in there, we're going to actually deploy the foundational infrastructure. Again, like Victor said, we're using actually our Cloud Shell console, and what we're doing there, we're actually setting up all the components of the game itself. So in our case, we're gonna set up the Kubernetes cluster. We actually have notification service, which is actually quite nice. That gives you, it can ping you the status and alerts to your email. Obviously secrets and vault and master key, things like, where we can connect and manage the database connection. And then there's a few policies and groups that also is going to be deployed for it to be able to run the whole solution. So Victor, do you want to show a little bit again the UI, the Kubernetes side, and maybe Vault, depending if we have enough time?
Sure. Let's share again the screen. and you should see my browser now. So now I'm in DevOps project, the overviews. So now the next step would be to go to developer services once again. And here in containers and artifacts, you will find most of the interesting part you are going to see on this content. That is the Kubernetes cluster, the container instances that will be used internally by DevOps, and also the container registry where you will have your images of your containers, your artifacts. On the container cluster, you will see that we have the Kubernetes cluster with one node pool that contains 2 nodes. And if you click there, you will have access to your Kubernetes cluster. So you can configure it through Cloud Shell. That is kind of like a small virtual machine that runs inside of your tenancy. That is free and basically has all the tools installed. So you can actually, without installing anything on your computer, you can do all the stuff directly from there. You can enhance your cluster with extra functionality. And yeah, that's kind of the idea. You will have here the node pools with one pool and inside 2 nodes that you will also see from the compute instances website. You can see the version and so on. That's the way you can create your Kubernetes cluster. As soon as you have that, in the content, it will happen automatically with Terraform, but if you do it manually, you will have your Kubernetes cluster, and then you create an environment on the OCI DevOps. So OCI DevOps will be aware that a Kubernetes cluster exists and is the target for all the deployments that way, with that environment that will point to that Kubernetes cluster. But it's pretty simple. I can also show it if we have time. But if we go to the OCI DevOps projects, inside of projects, there will be environments. And if we go to environments, I will have an OKE, Oracle Kubernetes Engine, that is pointing to that cluster. If I click here, I will come back to the website showing the Kubernetes cluster. So everything is connected, and that's the way things get deployed. The same will apply for compute instances, for container instances, serverless functions. Everything is integrated in one single platform.
Perfect.
Cool.
So the next bit is then deploying the DevOps infrastructure itself. So I think, yeah, we covered a little bit of that. So you saw the project, and this is essentially where we're running additional scripts to then build the project itself, and so on. So it's going to create the build pipeline, and it's going to create all the deployment pipeline for us as well, which is all pre-configured. So I think more interesting one is probably going into the build pipeline itself. So that way, you can see how easy it is to start deploying it, and also some of the specs of the command. So Victor, are you ready for that one? And then I guess maybe we can sort of club it all together, just conscious of time that the next lab is about the deployment pipeline. So maybe if you could just touch upon the build and the deployment pipeline as part of the next demo piece, that would be great.
Absolutely. Yeah, no problem. So back to the OCI DevOps project, where you have all the entities that depends on that project. And we have 2 interesting ones, as Wojciech mentioned, that is the build pipeline. So that is the build pipeline. We can click on that one. This one will be also created by the Terraform script. And the definition of this part, the flow, is based on a YAML file that lives off the root repository. So you can take a look as well. That is where everything happens, all the magic. In this case, it's a simple case, so for you to try out, but we have 2 stages. One is the build services that is going to transform that code into artifacts, and then deliver those artifacts. So that is where you decide, okay, this is going to be a file, a simple file, or it's going to be a binary, or it's going to be a container instance. So in our case, it's a container instance. So all of that will end up being an image inside of your container registry that lives inside of Oracle Cloud as well. How to run it? Manually, or you can create triggers. Actually, for those of you with a little bit of knowledge on Terraform, Terraform is not required for you to run all of this. It's just it's there doing the job for you. But if you pay attention to the Terraform scripts, there will be some parts that are commented out that will trigger, that it will create a trigger. So that means that every time there is a change in the code, it will trigger the build pipeline. And the same you can do to trigger the deployment after a build pipeline successfully run. In this case, I'm going to run it manually. I probably don't because time, but this is the idea that you can start build pipeline. You have environments, variables and parameters that you can configure. In this case, I'm deploying in Madrid region, but you can change that. And depending on that, it will end up being in a container registry inside of that region. I will cancel, come back, just to show you a little bit how will be the end result. If you go to the history, you will have one here. Well, in my case, I have one because I ran the whole content already. But this is the way it looks. It's the same with green, indicating that everything went well. You can take a look to specific parts of that stage. And then here you have everything connected with observability already, without you having to configure anything. And you can see if something happens, something that is not right, you can come back here and take a look and say, okay, it failed at this stage. What do I have to change? Come back to that, make the changes and run it again. So that's the idea to iterate your OCI DevOps build pipeline. And now coming back to the project. The other interesting entity is
there's some raised hand. I don't know, Violetta, do we want people to just raise it for the question?
I will chat. I'm going to send a message to Alessandros, and in case he needs our help, we can help him. No worries. Just focus on.
And then after showing all of this, I will take a look in the chats as well. If there is any question, outstanding question, I'll take it. And probably, I'm not sure, we may have some time for some questions at the end as well. So I see a Q&A anyway that is asking what is Terraform. Terraform is infrastructure as code. So you are actually coding the infrastructure and you just say, Oracle Cloud, give me this infrastructure. Terraform will talk to Oracle Cloud to create those resources. That is nice because you don't really have to go through the UI every time. It will happen automatically. And an important part is that as other questions has happened, you can do code reviews, you can take a look and reason about what is happening, what infrastructure is being created, all the interesting part from operations plus developers, having code to create system administration tasks. That is the concept. That is the important part of Terraform, is connecting those two worlds. And coming back to the deployment pipelines, the other part. Deployment pipelines is taking those artifacts and deploying them in Kubernetes in our case. So in this case, we have one stage inside of that pipeline, and it's going to deploy with customize. So it's going to execute customize. That is that specific way to deploy to Kubernetes cluster. And put all the images with all the YAML files, the resource, the deployments, the load balancer, the ingress controller, everything for the application to run, all the topology inside of Kubernetes. How to run it? Same thing, run pipeline, and then start manual run, or you can automate it based on previous stages. Parameters, in this case, we don't need any because some of the parameters are like internal and it's like secrets and things like that happens behind the scenes. You don't want a secret to be shown here. So some of those things happen already behind the scenes and you can take a look to the code and discover all of that. With that, I covered build pipelines and deploy pipelines. So we can proceed.
Proceed. So I don't think we need to cover this, but yeah, there's just conscious that I want to maybe open up for questions. But we did sort of build in as part of the steps a possibility to then, show you how to actually release new features. So it is relatively basic in the code, but yeah, it gives you kind of the the whole flow in terms of, okay, I deployed it now. I want to update something. I don't know. The example could be, I don't know, add new assets or add some additional, game logic or so. So we also, showed you how to actually do that. So as part of committing to your repo or changing your repo directly in GitHub. And that allows you then to build up the new pipeline and deploy the new version. As mentioned at the beginning, we also have the cleanup. So for example, if you're just doing it to play, the last lab essentially shows you how to get rid of and clean up your whole environment. So you don't have any sort of resources sitting in and running in the background. So so that's kind of just to kind of reiterate, you can do it yourself. You can either scan the QR code here, or you can follow the bit.ly link that I believe was shared in the chat. And I think that's all from us for the time being. So
I saw the questions already. So one of them is if this can be integrated with Azure DevOps. And the answer is that they are separate tools doing the same thing. So you can integrate before and after. That is true. So Azure DevOps can deploy into Kubernetes on Oracle Cloud. That would work perfectly. Of course, you have to figure out the latency, what type of networking you have in between the two cloud providers, but OCI supports heavily multi-cloud and connecting two clouds to work together. So that would be one scenario. But OCI DevOps works at the same level than Jenkins, Argo CD, Azure DevOps. They are all the same products solving kind of the same problems. That's one of the questions. The other one is kind of long, but it's kind of like trying to clarify the way I understand the question is trying to clarify how Terraform knows about images and container images to be deployed in Kubernetes. And the thing is that Terraform doesn't know. The one that knows about that will be OCI DevOps. DevOps is the one that take that infrastructure, plain and simple, without applications, and take the code and put the applications running inside of that. So Terraform is just creating the baseline, it's just creating the infrastructure and telling, okay, this is the infrastructure for you. It will output some values that we take from that to populate into OCI DevOps to do things like creating the environment. So OCI DevOps knows that there are code that will become container instances that will end up being run by Kubernetes. Kubernetes will be populated the same way as you mentioned on the question with YAML files. Those YAML files will reference those images, and that's the way Kubernetes knows about those images. How those images end up there? Because OCI DevOps. Hopefully I cover kind of like the general idea.
Thank you all for joining us. Thank you, Wojciech and Victor, for delivering to us.
Thank you for having us.
For being here. Thank you, Ettore, for all the help. Thank you, Tom. And I hope to see you again next week. Bye-bye and enjoy the rest of the day.